So I've just launched Blink from the middle of processing. I'm going to quickly open up a file and then I'll tell you what Blink is all about. So as I'm opening this up, Blink is an Isovist processing app for doing urban analysis with. So I've just opened up billintelligible.svg. So it reads in SVG files, which is the kind of files you can export from programs like Illustrator, and I'll do a second video about kind of making a file necessary. The key thing to observe is that unlike depth map, you will need to produce a boundary line around the limits of the system, and the program will automatically find the biggest boundary line. If you're having problems, it's probably not finding a boundary line. So what's the first thing we should do? Well, the first thing we should do is recognize that Blink has got no menus whatsoever. I'm sorry, this is quite an experimental app. So what you need to do is, after hitting O for opening up, you have to press N, and this will allow you to give the number of points. I'm going to do, say, 600 points. Now, I have the choice of either going G for grid or R for random. I'm going to use R because it looks quite cool. And you notice that when it's finished, you'll see all these little isovist dots. Now, at this point, the dots are translucent and meaningless. You can use plus and minus to make them bigger and smaller. Now, to move around inside Blink, you just click and drag to move it around. And if you want to zoom in and zoom out, it will zoom in and zoom out on the point. And then the first thing you will notice is if you click anywhere, it will then create an isovist for that point of view. So you can actually see the isovist generated there in thing. So these are all isovist generating points. We haven't yet processed the file, so we don't have any data on it. We just have a whole bunch of random isovists. So to process, we just hit A. A means all. Now, if you look at the individual processings, you can speed things up by just processing the elements you want. But at this early stage, you just want to process absolutely everything. So this will process traditional VGA. It will process traditional SVG. So it will produce overlapping asymmetrical isovist analysis, and it will also do a Jacobian symmetrical isovist. If you look in the background, you can see that it's all processing away. We're nearly done. Oh, and it's computed everything. So obviously I tend to compute everything from the command line, but you may get a different result. So here we go. The other thing we can do to make the color stand out is we can go B, and that makes the background black. That helps the colors stand out a bit more. You can do it on white if you're, say, printing, doing a PDF or for paper, for example, but the black background. So if you hit B, it flip-flops between a white and a black background. At this point, the top row of the keyboard is all the values. So let me just do them in order. We've got, that's connectivity, that's traditional VGA connectivity. We've got fractional connectivity, and we have got symmetrical fractional connectivity. So this is using area of overlap to calculate those last two. We can also select an item. So we can select an item down here, and we can go D, and it will compute the depth from that point. So this is the step depth. You notice that what it will actually do is also calculate the J graph from that point as well. We can do one from here as well. We can go D, and that'll calculate another depth. So when we go to this, what we're actually looking at is all of the step depths. Effectively, this is the integration value. So if we do 4, this is basically the equivalent to the integration value. It's just total depth. It's not been relativized at all. If we go 5, we get the same thing for fractional, asymmetrical fractional overlap. And if we go 6, we get the same thing for symmetrical total depth. So 7, 8, and 9 do the same thing, but what they do is they log the value. And this is kind of what integration does. It sort of stretches the values all over. and we can see that we get a nice kind of processing like that. So the first thing you want to do is you probably want to save a table of all the values, and you can do that by saving T, and that will generate the table. And if we go to Blink, you'll see there's a folder called table, and that's now got the comparisons, which we can open up with Excel. Here comes Excel, and we have the X and the Y coordinate, the VGA total depth, the asymmetrical total depth, the syntactical total depth, the VGA connectivity, asymmetrical connectivity, and the symmetrical connectivity. Notice these numbers are all negative, not because they are negative. It's just that in order to flip the color values around, so small is good, red, and large is blue, you have to use the negative of it. So that's actually not correct, but that's just a little thing. So you can export all the values for all the points there. It doesn't calculate any other other in Isovist information, but maybe it should do. And finally, we've also got, if I hit S, it will then generate an image, which it will then call. So it just calls it the name of the output. So it's output with the value of whatever you're looking at to actually, so you don't do it. So that is the VGA value. So this is a PDF, so it's a vector PDF, so it should print pretty well. It also includes the name of the value at the top, so you can actually fix it. So that is everything in one quick go. I'm hopefully will make another video that will actually produce a more longer form version of this. So thanks for listening.